Namaste students, so welcome back to daily practice session. So let us know about null point today. Okay, let us take an example. So take two charges, one is plus q and one is plus 4q. Okay, so they are separated by certain distance. Let the distance be some d. Okay, d is the distance of separation between that two charges. Now if you consider some point in between these two charges, okay, somewhere here, then at this particular point, let us name that as O. Okay, that point is O. Now at this particular point, the field due to this one, this plus q, will be along this direction, correct? No, because that should be away from that charge, positive charge. Therefore the field must be away from that particular charge. Similarly, due to this plus 4q, the field at this particular point will act along this direction. Why? Because in that case also, field must act away from this positive charge. So this is positive charge, so that must act away. Okay, now if this E2 and E1 has same magnitude, then we can say that at this particular point O, the net field is 0, correct? No, if E1 and E2 are having same magnitude, and if since they are acting in opposite direction, here the direction is opposite to each other. Therefore, if you have same magnitude, then this net field becomes 0. Correct? No? So that particular point is known as null point. Okay. So if you have two similar charges here, like charges, I have considered positive charges, right? Similarly, you can take two negative charges also. Okay. In that case also, at this particular point, you will get the direction of fields in opposite direction. Okay, opposite to each other. So that somewhere in between these two charges, we don't know exact value. If you have equal charges, then it will be exact at midpoint. But now you have q and 4q, it is not equal, right? Therefore, we don't know where the point is lying, that where that null point actually lies. So let us take that distance of null point from smaller charge as x. Okay, distance of null point from smaller charge as x. Okay, so now to calculate that x, we have one shortcut formula. Okay, so x is given by root q1 into d divided by root q1 plus root q2. So this is the shortcut formula to find the distance of null point from any one of the charge. This is actually from smaller charge. Okay, x is from smaller charge. That means always q1 is less than q2. You have to select the charges like this only. Okay, so if you have two charges, select smaller charge as q1 and larger charge as q2. So here, now in this particular case, so which is smaller charge? This one is q, smaller charge is q, right? Here q1 is q, and what is q2? That is 4q. Now just apply this equation here. So what do you get? X equal to root q into d divided by root q1, that is q plus root 4q. So what do you get? You can cancel root q. So here d, and this will be 1 plus 2. That means d by 3 you will get. Right? So the distance of null point from that smaller charge is given by d by 3. So you can make use of this shortcut formula to find the null point when you have two like charges. Same happens for two negative charges also. Okay, both positive charges or both negative charges, you can make use of this shortcut formula. So if you know the value of d, then just substitute that. Once if you get the value of this x, you can find the distance from larger charge also. How? That is nothing but d minus x, right? So total distance is d. So if you know x value, then you can write it as d minus x. Again, you will get the distance from larger charge also. Hope it is clear. So now if you have two unlike charges, okay, for example, one plus q and another minus 9q. Okay, minus 9q. That means one positive charge and one negative charge. Okay, in this particular case, you won't get null point in between. If you take this distance as d, between the charges you won't get any null point. You will get a null point somewhere outside. Okay, here or here you will get null point. Okay, usually we get the null point outside the smaller charge. So this will be the point where you will get zero electric field. Why? Because here if you take one point, okay, due to this positive charge the field will be along this direction, and due to this negative charge, this is negative charge, so the field due to this negative charge at this particular point will act in the same direction. Why? Because that is negative charge, so field acts towards that charge. Therefore here you won't get E equal to 0, it won't be equal to 0. Then possibility that at this particular point, so at this particular point if you take, this is positive charge, so due to that positive charge E1 act along this direction. Now due to this negative charge here, the field that will act in this particular direction. Why? Because due to negative charge that acts towards. So here you have a possibility that E becomes 0. Okay, and also here also, what you can what is the direction of E1 here? So due to this E1, it must act away. That means E1 is acting along this direction. But what about this E2? Acting towards, right? So that will act along this direction. Okay, so that here you may get E equal to 0. But this is also not possible at all. If you consider exact concept, if you know, you won't get E equal to 0 here, because this is larger charge. Sorry, the magnitude is large, right? If you take 9 and 1, this has more value, right? So due to that here E2 will be very large. E2 will be very large. But if you have same amount of opposite field due to this, then you can get here electric field as 0, but you won't get E1 as much large as that of E2, because the distance from here to here is very large. Distance from plus Q to this particular point is very large, so E1 will be very small compared to this E2. Therefore they won't cancel each other here. Okay, therefore here you won't get E equal to 0. The only possibility that this particular point, because here due to this plus Q you may have a smaller field. Okay, smaller field here. Okay, because magnitude is small, but the distance is small. Therefore if you have some value here E1, now if you take this one, due to this larger magnitude, as you have a stronger field, but as you move away from this particular charge, the intensity of field goes on decreasing. Okay, intensity of field goes on decreasing, so that you can have same amount of E2 which is equal to E1 in opposite direction here. So this one is has more this is the more correct option we can take. Okay. Yes, now for this particular case, what is the value of Q1 here? That is Q. And what is the value of Q2? That is minus 9Q. Okay, so here if you want to get the null point, if you take this particular distance as X, okay, again that is from smaller charge. So here if you want to get the value of null point, you can use this shortcut formula, that is root Q1 into D divided by root Q2 minus root Q1. Okay, in previous shortcut we have considered root Q1 plus root Q2, but here root Q2 minus root Q1. Okay, again here Q1 is less than Q2, that you have to remember, and X from smaller charge. Okay, so X is from smaller charge, that is from Q. Okay, in this particular case that is from Q. So just substitute the values. What do you get? X equal to root Q into D divided by root Q2, that is 9Q minus root Q. So what do you get here? Root Q can be cancelled, right? So D root of 3, that is 3 minus 1, that is D by 2 you will get. Okay, I think this shortcut is helpful for you. Okay, if you have similar charges, root Q1 plus root Q2, and or like charges, root Q1 plus root Q2, and for unlike charges, root Q2 minus root Q1. Okay, yes, thank you.